So let's look at just a little bit more about summation. This time do it with a geometric sequence. This was b sub n from the first of these three videos. Um, and it's a geometric sequence, 18 minus 6, 2 minus 2/3, etc. And right now we're going to look at the finite sum of these things, and specifically going to minus 2 over 3 to the 11th. Because what we figured out about b sub n, and what you need to figure out, or it's very helpful, if you're going to do this kind of summation efficiently, is the master formula. And we figured out it was 18 times minus 1/3 to the n minus 1. And that starts out with 18 and then multiplies it continually by minus 1/3. We get that. Like here, the ratio is sort of more clear. Okay? So let's actually go ahead and write this out in the sigma notation. Not because it's, well, actually no, let me postpone that. I want to emphasize that you don't have to do the sigma notation for this. The sum is, our formula is a times 1 minus r to the n over 1 minus r. And this n can be the trickiest bit about, well, what is that n? Is it like 11? Is it 10? Is it 12? What is it? Okay. Well, the a is always the first term. Okay, so that's always 18. And then you're continually multiplying that times powers of minus 1/3. And the main thing is that this guy is n for next. It's whatever is the next one that you didn't use. So here, what am I doing? This is still a little tricky because we have to express this in the pattern. It's 18 times what? Times minus 1/3, and this is a very common thing with any kind of sequence or summation, is to make sure you understand how that last term fits into the pattern. So that's minus 1/3. Well, let's see. If it was to the 11th, then I get 18 over 3 to the 11th. Okay, that's not going to work. Okay, so if it was to the 13th, though, okay, that's 2 times 9. Let's factor out the 2 in here. Times, over 3 to the 13th. And then a minus 1 to an odd power is negative. Okay, so those match. Yes, the 2 matches. And then 9 over 3 to the 13th, that's 3 squared over 3 to the 13th is 1 over 3 to the 11th. Okay, so we had to carefully match and make sure we know what power that is. Okay, so that's really a matter of solving equations involving exponents. So this guy is going to be 1 minus, so this is a 1 minus a minus 1/3 down here. And then this is 1 minus minus 1/3. And then the next power, we are using the 13th power, and that's going to be the 14th power. Okay, so really it's about getting a careful sense of how these numbers, oops, no, I don't want the auto updater to do anything. It's about getting a careful sense of how these numbers fit into the general pattern, so you know what the last power was, and then you can just do the next power. Okay, we can simplify that a bit. Okay, the 1 minus a minus 1/3, that's over 4/3. So in other words, it's 18 times 3/4. And then times 1, and then this is an even power, so it's plus, and then the minus sign stays there, so 1 over 3 to the 14th. Okay, so that is, let's see, 18 times 3 over 4, that's 27 halves. That's how it simplifies. And then times a number that's incredibly close to 1. You can get it on your calculator, but it's really close to 13.5. Okay, so let me show you how to write that as a summation. Let me just take out, well, let me see if I can slide it in right up here. Oh, I got this too. Got a lot of room up here. Okay, so this is going to be, if you want to write it in a fancy way, or if it's given to you in the fancy way, it's going to be sum, let's say k, you can use whatever letter, it's a dummy variable, and more often than not it's going to be 1. Okay, so this is going to be the first term in the sequence. And another way to describe this key calculation here was figuring out which term in the sequence this is. It wasn't the 11th term. Okay, this was when the power was 13. But I'd like to express it in this way. If that's a k, say. Okay, I'm purposely using a different variable here because it can be nice to use a different variable for the summation variable that's kind of a counter that's running while you're keeping track of the summation, and n, which often you want to think of, and in fact here you always think of, as labeling how far the actual end of the sequence is. It's a tricky thing between dummy variables, which just go temporarily keep track of the terms in the summation, and a variable that actually tells you where the end of your particular summation is. Okay, so what was the deal? The key thing is that that power was 13. I fit it into my standard pattern. If the way that I label that pattern is k minus 1 in the exponent, then this had better go to 14. It's this tricky thing about k's, k minus 1s, 13s, 14s, that really has to do with the fact that we started counting at 1. Why do we put a k minus 1 here? It's because if we start counting at k equals 1, that's the way to make this all die at the very first one, and so that this really is the first term displayed. And that's a nice thing, is that this should be the first term displayed explicitly, and so this should die. That forced us to have a k minus 1 here, and that forces this to be 14, so that this power is 13. Might be a little, I think it's the tricky part, and we just got to practice it. Okay. Now, you could use a different label. K goes from 1, 2, 3, 4. I could use another label like J. Maybe I could have that be 0, 1, 2, 3. So I could label them. J goes 0. Okay, well, that's lagging 1 behind, so it's going to go 13. The advantage of that is now the power starts at 0. I don't have to slide it over by 1. These powers start from 0 and go up to 13, which is exactly what I wanted them to do. These powers start from 0, because it's 1 minus 1, and go to 13, 14 minus 1. These are exactly the same expression, just a different labeling. I'm not saying you have to answer both versions, but you need to be able to deal with both versions, because you've seen in problems in the book that sometimes they'll throw this at you, sometimes they'll throw this at you. They're both really legitimate. Okay, so these problems can come at you in various ways. We could have, here's the sum, and we need to figure out exactly the indexing and what the details are and give the summation, and then maybe package it up as a sigma, or maybe it's given as a sigma. If that's true, if it's given as a sigma, the first thing you should do is at least get the first and last term explicitly. That's a really important thing. While we're on the subject of this summation, what would happen if we wanted to sum the whole sequence? That's a little bit more of a sophisticated concept, but it's actually a simpler formula. If you had 18 minus 6 plus 2 minus 2/3, and you never stopped. By definition, that's the trend. And what happens there is you get a somewhat simpler formula. It's just a over 1 minus r. The whole 1 minus r to the n thing goes away, and in particular, the trickiest thing goes away, which is where did you stop and how do you label it and what's the n? That's really great news that it just goes away. That was the 18 times 3/4, and that is, let's see, yeah, and that was the 27/2. Ta-da! That's a nice simple thing. So this is a good thing about infinite series. We use the term series, not a sequence, when it's an infinite one. Is that all that messy stuff about where does it stop can't possibly affect us because it never stops. Okay, that's. Oh yeah, one more. It's getting a little long, but I think I want to just go ahead and do it on this one. Yet another one. Let's package up. Let's that sequence C sub n, which was minus 1 to the n plus 3 over 10 to the n. So if you didn't watch the video where we did that, there's a sequence for you. Okay, it is minus 4/10, then 5 100ths, then minus 6 1,000ths, etc. Where these are going up by powers of 10, these are just going up linearly, and then you have alternating sign. So what if I wanted to package up one more time, because this is one of the trickiest things. If I wanted to package up the summation out to, let's say, pretty far, let's say plus 14 over, actually minus 14, over 10 to the 11th. What if I wanted to write that in the fancy summation form? What's going on here? Well, again, we just need to figure out, okay, we got the formula, that's nice. And if you didn't have the formula, that'd be the first thing you would do, and you should look into another video for that, the sequence examples video. But here's that general formula, and then the key thing is just where to start and stop. Let me go back to k here. So I was kind of making this point that k is maybe a better variable as a summation variable. Okay, well, is it k equals 1? Let's see. Does this start with k equals 1? Yeah. Minus 1 to the 1 is minus. 1 plus 3 is 4. 10 to the 1. Okay. And then I just need to figure out the match on where to stop. That's mainly the main thing. All right, well, the nice thing is this is really just 10 to the k, and it's just sitting there. But we better check it. Minus 1 to the 11, that's an odd power minus 1, that's minus. And 11 plus 3 is 14. So there's how you would package that sucker up. All right, that's plenty long for this video.